So, folks, now remember, you're welcome to do your own work. Just keep the noise level to it, and you're welcome to work together. Just keep the noise level low enough so I can hear myself, and people who are working on number 3 with me can hear it also. But if you don't have your own assignment open, I would strongly suggest using one of our computers or your phone to have it open rather than trying to wait and duplicate what we do later. Well, it's Melrose, HS, or Melrose High School, and then .MA, because we live in Massachusetts. Well, no, I'm trying to show you the logic so that next time you can forget again. It'll maybe trigger through the logic. Number 3 now. All right? Where you got the soccer player who, really what they're telling us is that this kicking it directly in, would that be the distance or the displacement? Right, it would be the displacement, because it's just from where it started to where it ended, including direction. And they're really asking us to find the components of that. So I'm going to grab that because I don't feel like redrawing that diagram, since that diagram is nicely already a vector diagram for me. And all I need to know from here is that the length of my R vector is 7 meters. And I think that's the value that's different for all of us. So this is problem number 3. And they tell me that this line is 7.0 meters long. So that would be the Y I was looking for, in the form of a vector diagram there. And now I'm looking at this, and I have a right triangle, and so I know some things about right triangles. Oh, I did update the equation sheet. So if you go, you can find it a couple of places, but as you're doing homework, probably the easiest place to find it is right on the front page of WebAssign. When you go in, there's class resources, and I put an updated equation sheet in there. And the main thing that I updated here was this trig section with the SOHCAHTOA definitions in there for you. So if you're having trouble remembering SOHCAHTOA or just not used to using it, which I know is the case for some people, it is right there on our equation sheet now. So hopefully that is helpful to you. So I'm looking for the components here. RY is adjacent to the angle, and RX is opposite the angle that I know. So let's see. They want RX first, so we might as well do RX first. RX is the opposite, right down here. So from SOHCAHTOA, I know that sine of the angle, which in this case is 30 degrees. So I have sine equals opposite over hypotenuse. The opposite is RX. The hypotenuse for me is 7.0 meters. I need to solve for RX, so I'm going to bring 7.0 meters up. The other side, sine 30 degrees equals RX. Got my calculator. And 7 times sine of 30 is 3.5. So I get 3.5 meters equals RX. wanted to make sure I put that at 3 sig figs. Good point. Practice what I preach, right? I should write 3.50 meters. Sorry, I got lazy there on a Monday. And I'm going to double check that to see if it's right. 3.50 meters. And I look at my direction. And my direction, I agree, they already gave me the diagram. My direction is east. I'm going to check those. Yes, it is set for each, only to submit things when you change them. So if I had screwed up and picked west, and I only wanted to change west, it would only submit when I changed. I'm about to. I'm going to do the other component. That's okay. Not a problem. And remember, if you miss any of this, it's up as a video and also up as a PDF of this, what I'm writing on the board. So now I'm going to look for the other leg of the triangle, the adjacent side, because that component is r sub y. And if it's adjacent, the trig identity that I think of is cosine. So I've got cosine equals adjacent over hypotenuse. That's the ka part of SOHCAHTOA. And so I have cosine of 30 degrees equals adjacent, which is r sub y, over hypotenuse, which is 7.0 meters. Rearrange, 7.0 meters, cosine 30 degrees equals ry. I have all numbers on one side, which makes me happy. And I get 6.06 meters. And from my vector diagram, I have that pointing south. 6.06, that's what I get. Let's see if it's right. 6.06 south. And that comes up correct. So, we're looking at number 10 here. And number 10 is actually, it's a good change from follow-up to number 3, because in number 3 we are given the displacement vector and said find the components of it, find the horizontal and vertical parts that make up that vector. Now in 10, we're given the horizontal component and the vertical component and asked to find the vector. The only thing we want to be careful of is what angle they're asking us to find. So let's grab this. Let me make sure I'm on the new page here. Grab this and we'll get this going, and this will be good. This will be the opposite function of what we did last time. Should be a good thing. Okay. Let me transfer over a little information here. They tell me nicely. They gave me the vector diagram again, so I didn't have to draw it again. But this is exactly this part here. This triangle is exactly what I would expect as a vector diagram. And on the test, that would get 100% this triangle here. All right. So facts that they tell me. They tell me my vector west is 18 meters. My vector north is 25 meters. They want to know how long my displacement vector is, which is my vector r. and then the compass direction of that displacement vector west of north. So they want to know the angle that is west of north, which means I started pointing north, which they have labeled Y here in their diagram, and then I turn that many degrees west. I started west of north means starting north and swinging west. So the angle they actually want me to find is that angle right there. That theta is what they're looking for in my answer. Oh, that's a bummer. That's outside the triangle. That's too bad. I only know how to do angles inside a triangle with SOHCAHTOA. Sarah? Like here? That's theta, by the way. So you're saying find this angle. Ah. So I could find this angle, which let's call it phi. Phi. Or phi. I actually wrote phi. And you're saying that those two would add up to 90. Yep, that's true. Is there any other angle that would be the same measurement as theta, but inside the triangle? Well, this one would be 90, right? That makes it a right triangle. The one up here would be theta also. How do we know? Well, we know that from outside here, theta plus phi add up to 90, and we know the interior angles add up to 180. The other way to think about it, if you remember back to geometry, alternate interior angles of parallel lines, well, these two are, the two thetas are alternate interior angles of parallel lines. So whichever way makes sense to you. For me, it's remembering this and then 90. So, do you guys want to solve for theta or for phi? I personally would rather solve for theta because then I don't have to remember to subtract it from 90 to get the answer they want me to enter. So that's what I would prefer to do. Is that okay with everyone? We'll solve for theta? Sure, why not? All right, so we know the two legs of our triangle here, and we want to know the hypotenuse of it. So I'm going to do Pythagoras, which is a squared plus b squared equals c squared. And my a here is 18 meters, so that squared plus my b is 25 meters. And my c is labeled r, so that'd be r squared. I'll tell you the most common mistake mathematically next is to solve for r squared, not r. So be careful of that. So I get, doing this math, 949 meters squared equals r squared. So if I square root that, I get 30.8 meters equals r. Think I should check it or trust myself? That's right. You have the same 25 and 18? Glad I got it right there. Yes. Let me look what you do. That's because you are using this for those will X for this. That's like third root, cube root, or the quad. You know, use the just straight square root there. All right, now I need to figure out my angle theta. I have lots of information. but I'm gonna use that I know the opposite side. What's the opposite side to theta? What side, not angle, what side is opposite theta in my triangle? In my triangle, the green one. No, there's only one green theta. The other one is phi. Sorry, phi. Why am I up on phi? The other one's phi. So what side is opposite the green theta? 18 meters. Side, London. Side, not angle. That's okay. What side is adjacent to theta? No, one is the hypotenuse. It's only one side that's adjacent to theta, and that's the 25 meters. So I have the opposite, I have the adjacent, and I look at my equation sheet. Well, okay, that's a valid question. It's a valid question. The way I know is I'm looking at this and thinking, what do I want to find this angle. What information do I have? I've got the length of two sides, the 25 and the 18. How are those related to the angle? Well, one is opposite the angle, and one is adjacent the angle. Right? One's next to it, and one's across from it. And then I go and I look at my equation sheet and say, do I have any relationship that relates the angle to the side opposite it to the side adjacent to it? And tangent relates the angle theta to the side opposite it to the side adjacent to it. All right? So that's really, I'm looking at what I have and trying to figure out how can I get what I want. So I'm going to do that tangent of theta is the opposite side, which is 18 meters, over the adjacent side, the one next to it, which is 25 meters. Right? Everyone see how I got those to fill in there? Now, the problem is I don't really care what tangent of theta is. I want theta. And remember, mathematically, to get something by itself, you have to do the inverse function, the reverse function. That's how, so on to each side, to this side I'm going to do tan to the -1, which is arctan or inverse tan. To this side I'm going to do tan to the -1. All right? And tan to the -1, what would tan over tan be? It'd go away, right? Not 0. It'd go away and I'd be left with theta. Not exactly how the math works, but it's close enough for understanding. Tan to the -1, therefore, of 18 meters over 25 meters. And then I do that. I do second tan on my calculator, so I get inverse tan. 18 divided by 25. I get 35.8 degrees. That's what theta is. And that's what I wanted to find out. 35.8 degrees. Yes, ma'am.